Hello, mathematicians. Today we are doing topic 5 review, the final topic, everything calculus. Let's get started. Okay, first up we're going to look at some differentiation techniques. So just remember that differentiation is simply rate of change. We're looking for the gradient of a curve. The notation that you'll see is as follows. So you might see the Leibniz notation or Newton's notation with f of x. And this just gives the change in y for every unit increase in x. Okay, going back to our basic idea of slope. Now, the most commonly used differentiation rule is the power rule, which states that if I wanted to find the derivative of a times x to the power of n, I drop the exponent down as a coefficient and I subtract 1 from the exponent value. We also have a ton of other differentiation rules and properties. Another one being if I'm taking the sum of two different functions, I simply take the derivative of each one and get the sum or difference. The next one here is the product rule. This is where things get tricky. So we do not simply just take the derivative of u and multiply it to the derivative of v. The product rule looks like this, but it's always good to have memorized and easily accessible so you're not constantly referring back to your formula booklet. And at this point, we should all have internalized the product and the quotient rule. So the quotient rule is trickier because the order in which you take the derivative of the top and bottom or numerator and denominator function matters. So you want to first take the derivative of the numerator, multiply it by the denominator, and then subtract the numerator multiplied by the derivative of the denominator, and then square the denominator function. All right, then we have our e to the x function, our ln function, as well as our trig function sine and cosine. Now, if we are graphing, remember that stationary points occur whenever our derivative is equal to 0. So we're looking for horizontal tangent lines. There are three possible outcomes when we set the derivative equal to 0. We could either get a local maximum, and if I were to look at the sign diagram, I'll see that to the left and to the right of our value of interest, x equals a, I see that the function first increases, meaning the first derivative is positive, then decreases. That tells me I have a local max. In contrast to that, if I see that my first derivative is negative and then positive, meaning my function decreases and then increases, I have a local minimum. Now for stationary points of inflection, the sign does not change to the left and to the right of my critical value. And these are the two possible outcomes. Okay, so it could look something like this. When we're looking at our second derivative, this tells us about the concavity, whether or not the function concaves up, opens up, or is concave down. In the case where our second derivative is concave up, we have that it is positive. Second derivative is negative, then we have a function that is concave down. Now, when we're talking about stationary points of inflection, notice that the tangent line at these points are horizontal. When we're looking at non-stationary points of inflection, so this is when the first and second derivative is equal to 0, the difference here is that for non-stationary points of inflection, the tangent line is not 0, meaning that the concavity to the left and to the right of our point of interest changes. So there is a sign change for the second derivative. And when exam papers ask about points of inflection, they're usually talking about non-stationary points of inflection. Okay, before we move on to the practice problem, let's look at the different uses of differentiation. The first is curve sketching. So we've talked about looking for maxes, mins, points of inflection, and so on. we might be given optimization problems. And in these cases, you're usually setting the derivative equal to 0 and looking for maxes and mins. You might be asked to find tangent lines and normals. Remember that normals are perpendicular to the tangent. Here's a reminder of the GDC buttons that you may find helpful on a paper 2 exam, okay, when looking for either the derivative or the tangent lines. Finally, we have kinematics. Okay, so S of t represents our displacement function. When our displacement is equal to 0, this means that our point P, or the particle P, whatever we're looking at, is at the origin. When the displacement is greater than 0, it means that the object is to the right of the origin, and when it's less than 0, it means the object is to the left. So it tells us about the displacement, how far away from the origin. The derivative of displacement gives us velocity. So when velocity is 0, means our object is at rest. When it is greater than 0, it means it's moving to the right in the positive direction. When it is less than 0, it means it is moving left in the negative direction. And if we take the derivative of velocity, we then get acceleration. So whenever acceleration is greater than 0, it tells us that our velocity is increasing. When our acceleration is less than 0, it tells us that velocity is decreasing. Whenever acceleration is equal to 0, it means that our velocity is either at a max or min. Now remember that speed is the absolute value of velocity, so we don't care about the sign. And then lastly, how to recognize if something is speeding up or slowing down is that if you see that the velocity and acceleration have the same sign, then it means our speed is increasing. If you see that the velocity and acceleration have opposing signs, it tells us that the speed is decreasing. There are 3 questions to try in this next section. Set a timer for 15 minutes, attempt all 3. Everyone should be able to do the first 2 and try to get as many points as possible for the last question. So go ahead and pause the video and try these questions now. Here's the mark scheme. You can check your answers. All right, on to the next section. So we're going to start off by looking at integration techniques. Remember that integrals are antiderivatives, and they also tell us about areas under curves. The most common antiderivative you'll be asked to find is the reverse power derivative, antiderivative. So this one tells us if I want to take the integral of x to the power of n, I first add 1 to the exponent and then divide by the number that I just wrote down. If we're looking at an indefinite integral, don't forget your constant of integration. And of course, you'll need some additional information if you're asked to solve for c and find that specific function. Now with definite integrals, you're asked to evaluate at some lower and upper limit. So when you have your GDC, you can use the math button to find that. Here are some common integrals that you'll be asked to find. So pause for a moment and see if you remember all 4. First one is minus cosine x plus c. Antiderivative of cosine is sine. E to the x is just e to the x. And if I see 1 over x, this antiderivative is ln, absolute value of x. And of course, don't forget your constant of integration. Okay, so for linear compositions, this is when we're replacing x with some linear function. ax plus b. Some examples of this, so these ones should be easily done and you can do them via inspection. We want to recognize the composition first of all as linear, and then we take that a value, take the reciprocal of it, and that becomes a coefficient. Everything else stays the same and we add our constant of integration. So here are two examples. There's also the reverse chain rule, which takes a little bit more practice to recognize. It is in the form g prime of x times f of x times f of g of x dx. Okay, so the integrand here is a composition where one of the factors is the derivative of the thing that is in the composition. That was a mouthful. So see if you can figure out the antiderivative of sine x over cosine x. And you can also make a useful substitution in this case. All right, check your answer. Next up, some uses of integration. So we can use integrals to find areas between 2 points or between two curves. And when we're finding the area between two curves, remember that we first need to locate the points of intersection first, and we're taking the upper function and subtracting from the lower one. So this work is much easier on the GDC. You can actually just take the absolute value of the integrand. Otherwise, you'd have to take some time and actually set up this example, for instance, into two separate integration problems. Okay, and then with regards to kinematics, recall that displacement is looking for the integral of velocity, whereas distance is asking for the integral of the absolute value of velocity. Again, set a timer for 15 minutes. Try the next few questions. Okay, so hopefully everyone was able to get the first 3 questions at least within that time frame. You can check your answers. And that concludes our lesson for today. I know I went quite fast. If you have any questions, please do come see me. I'm available before and after school, and hopefully you have that gift for me from Songkran Holiday. Remember, I gave you some exam papers, so be prepared. Revise those papers. The mark schemes will be posted soon. And we have a test next class on topics 1 through 5, and this test will be paper 2 only. All right, good luck. See you next class.